నిన్న మెటీరియల్ అడిగారు కదా, గూగుల్ క్లాస్ రూమ్లో పోస్ట్ చేసిన మెటీరియల్ అంతా చూసారా?
సార్
సో అట్లీస్ట్ దాన్ని తీసుకుని ప్రిపేర్ అవ్వండి ఎగ్జామ్కి. రాజ్కుమార్ మంచాల ఇట్లా జరుగుతున్నాడు. ఏమ్మా రాజ్కుమార్, హలో వెళ్ళాడా? Test Sharan is there. Roll number 3, LE3, LE3 LE2 మెటీరియల్ అడిగింది ఎవర్రా? మెటీరియల్ ఆల్రెడీ పోస్ట్ చేసే క్లాస్ రూమ్లో చూసారా?
సార్
సో ఇప్పుడు ప్రిపేర్ అవ్వండి, చూద్దాం ఎంతవరకు ప్రిపేర్ అవుతుందో చూద్దాం. ఎప్పుడు ఎగ్జామ్ మీకు? నెక్స్ట్ వీక్ నుంచి కదా ఎగ్జామ్స్.
సార్
క్విజ్, ఆబ్జెక్టివ్ టైప్, డిస్క్రిప్టివ్ రెండు ఉంటాయి కదా సేమ్ డేనే?
అవును సార్.
ప్రిపేర్ వెల్. సో ఆబ్జెక్టివ్ టైప్ మీకు గూగుల్ క్లాస్ రూమ్లో గూగుల్ ఫామ్ లాగా వస్తుంది, దానికి ఆప్షన్స్ పెట్టాలి మీరు అంతే. డిస్క్రిప్టివ్ ఏమో రాసి అప్లోడ్ చేయాలంట, పేపర్ మీ రాసి షీట్ అప్లోడ్ చేయాలి. ఎనీవే అది ఎగ్జామ్లో జాయిన్ అయినప్పుడు వాళ్ళు చెప్తారు, ఎగ్జామ్ ప్రొసీజర్ ప్యాటర్న్ అంతా ఇన్విజిలేటర్ వాళ్ళు చెప్తారు మీకు. సో వీఆర్ నాట్ గోయింగ్ టు డిస్కస్ దట్ నౌ. 48 members are joined. Still we'll wait for some 2 more minutes, then we'll start the class. You see how many are going to join. That Rajkumar is not there, he is not joined. He is there, na? Rajkumar, are you able to hear me?
Yes sir.
Why you joined through Google Classroom or with some other link?
Link sir, one link sir.
Link in the classroom or WhatsApp?
WhatsApp sir, WhatsApp link.
WhatsApp link ఎలా వచ్చిందా నీకు? లింక్ ఎలా వచ్చింది నీకు? WhatsApp లింక్
సార్ గ్రూప్ లో షేర్ చేశారు సార్, లింక్ జాయిన్ అయినా సార్.
ఎవరు షేర్ చేశారమ్మా? ఎవరు? నేను షేర్ చేయలేదుగా. ఇట్లా వాట్సాప్ లింక్ ద్వారా నువ్వు కనెక్ట్ అయితే ఏంటంటే ప్రతిసారి అది నాకు నేను అడ్మిట్ చేయమని నాకు వస్తుంది, నేను అడ్మిట్ చేస్తేనే నువ్వు జాయిన్ అవుతావు. అట్లా కాకుండా నీకు క్లాస్ రూమ్ ఇన్విటేషన్ పంపించే కదా నేను, వచ్చిందా నా దగ్గర నుంచి నీకు ఇన్విటేషన్?
రాలేదు సార్, నేను రీసెంట్ జాయిన్ సార్, నిన్నే జాయిన్ అయ్యాను సార్.
అవునరా, నిన్నే జాయిన్ అయ్యావు. నిన్నే నీకు మెయిల్ ఐడి క్రియేట్ చేసి ఇచ్చారు వాళ్ళు. నీ మెయిల్ ఐడి తెలుసా నీకు?
తెలుసు సార్.
ఏంటది?
రాజ్కుమార్ మంచాల 777 సార్.
అది కాదు. సో కాలేజీ డొమైన్లో ఈ జీమెయిల్లో అకౌంట్ క్రియేట్ చేశారు నీకు. ఏంటంటే నీ రోల్ నెంబర్ ఉంది కదా?
ఎస్ సార్.
నీ రోల్ నెంబరు @pvpsiddhartha.ac.in. మీ కౌన్సిలర్ ఎవరో నీకు పంపించుంటారే.
అంటే ఈ రోజు మధ్యాహ్నం పంపిస్తా అని చెప్పారు సార్, రఘురామ్ సార్.
అదే మేబీ ఆ మెయిల్ ఐడి ఉపయోగిస్తే ఏంటంటే నువ్వు ఆ జీమెయిల్ ఓపెన్ చేస్తే నీకు ఆ అకౌంట్ ఓపెన్, నువ్వు ఇది చూసావు, దీనికి రాదు, ఆ అకౌంట్కి పంపించాను నేను. ఆ అకౌంట్ ఓపెన్ చేసావు అనుకో, దాంట్లో ఈ క్లాస్లో జాయిన్ అవ్వమని నీకు ఇన్విటేషన్ వస్తుంది.
ఓకే సార్.
దాంట్లో జాయిన్ అయ్యావు అనుకో, ప్రతిసారి డైరెక్ట్గా నువ్వు లాగిన్ అవ్వచ్చు. నువ్వు వాట్సాప్ లింక్ ఇదేం చూడక్కల, డైరెక్ట్గా క్లాస్ రూమ్కి వెళ్తే దాంట్లో లింక్ ఉంటుంది, ఆ లింక్ మీద క్లిక్ చేస్తే జాయిన్ అవ్వచ్చు. ప్రతిసారి నిన్ను పర్మిషన్ అడగదు. ఇంకా ఇప్పుడు నువ్వు నీ జీమెయిల్ నుంచి వస్తున్నావు అనుకో, ప్రతిసారి నువ్వు క్లాస్లో జాయిన్ అవ్వడానికంటే నువ్వు రిక్వెస్ట్ పెట్టాలి నాకు. ఆ రిక్వెస్ట్ నాకు వస్తే నేను యాక్సెప్ట్ చేస్తేనే నువ్వు క్లాస్లో జాయిన్ అవుతావు. ఈ ప్రాసెస్ అంతా లేకుండా ఏంటంటే దాంట్లో జాయిన్ అయితే ఏంటంటే డైరెక్ట్గా జాయిన్ అయిపోవచ్చు. నువ్వు మళ్ళీ పర్మిషన్ అడగల్లా, రిక్వెస్ట్ అడగల్లా, నేను యాక్సెప్ట్ చేయగల. అది ఈజీయెస్ట్ ప్రాసెస్ అన్నమాట.
ఓకే.
అది మేబీ అదే రఘురామ్ గారు పంపిస్తున్నాము. పంపించిన తర్వాత ఇది యాక్టివ్ ఆ అకౌంట్ ఉపయోగించి లాగిన్ అవ్వు క్లాస్లో.
ఓకే సార్, థ్యాంక్స్.
అట్లానే ఇప్పుడు నువ్వు అటెండెన్స్ పోస్ట్ చేయాలి కదా. ఇప్పుడు అటెండెన్స్కి ఏంటంటే నేను క్లాస్ రూమ్లో లింక్ పెట్టా, అటెండెన్స్ నువ్వు అటెండ్ అయిన అటెండెన్స్కి. సో అదేంటంటే నీకు ఆ అకౌంట్ ఉంటేనే నీకు యాక్సెస్ అవుతుంది, నీకు ఇప్పుడు రాదు.
ఓకే సార్.
మేబీ ఈ 2 రోజులకి ఎట్లా ఈ రోజు క్లాస్కి ఏదో చూద్దాము, నెక్స్ట్ క్లాస్ అన్వాట్స్ దాంట్లో లింక్ అయితే నువ్వు అటెండెన్స్ కూడా ఇచ్చేయచ్చు దాంట్లోనే.
ఓకే సార్.
రైట్. సో ఇంకా ఇంకోటి ఏంటంటే ఇప్పుడు ఆల్రెడీ ఆల్మోస్ట్ 2 minutes అయిపోయినాయి మరి మనకి. సో ఇప్పుడు వచ్చి జాయిన్ అయ్యావు నువ్వు. హౌ యూ కెన్ పికప్ ఫ్రమ్ దిస్ పాయింట్. సో అంటే మిగతా ఎట్లా కవర్ చేయగలవు, మిగతా అయిపోయిందంత నువ్వు?
సార్ నోట్స్ అడుగుతాను సార్, నోట్స్ అడుగుతున్నాను సార్.
నోట్స్ ఉందా నీ దగ్గర?
అడుగుతాను సార్, తీసుకుంటా సార్ ఎవరో ఒకళ్ళ దగ్గర.
ఎవడు రాయలేదు నోట్స్, ఇప్పుడు అదే కదా ప్రాబ్లం. ఎవడు నోట్స్ రాయాలా? నన్ను అడుగుతారు ప్రజెంటేషన్ పీపీటీలు ఏంటి సార్ అని. అదే పీపీటీలు అదంతా కావాలంటే నీకు క్లాస్ రూమ్లో ఉంది, ఆల్రెడీ క్లాస్ రూమ్లో పోస్ట్ చేశాను నేను మెటీరియల్ అంతా.
ఓకే సార్.
దాంట్లో లాగిన్ అయితే యూ కెన్ యాక్సెస్ ఆల్ దోస్ థింగ్స్ ఆల్సో. మీకు కావాల్సిన ఇన్ఫర్మేషన్ అంతా క్లాస్ రూమ్లో దొరుకుతుంది, సబ్మిట్ సంబంధించిన అంతా.
ఓకే సార్.
ఓకే. సో ఎనీవే, సో విల్ స్టార్ట్ నౌ. So in yesterday's class we discussed about riveted joints, and then what is a riveted joint. Then we discussed about what are different types of riveted joints. We discussed all those things. So I think I am not going to that again. Basically there are two types of joints in case of riveted joints. One is lap joint, other one is butt joint. So here, if you look at the lap joint and butt joint, if you compare their relative merits and demerits, or relative, I can say merits only, not the advantages. See here, if you take a lap joint here, so before going into the design, these things are also important. So why, in what situation you are going to prefer lap joint? In what situation you need to go for butt joint? Or why will prefer this one butt joint in case of boiler shells, or why will use this lap joint in case of structures? Like that we want to see. The only disadvantage of in case of lap joint is, see this is the lap joint. So this lap joint is subjected to some force here on either side. The tensile force P, let us say it is P. So now you can see the front view and top view of the joint here. So here this is the front view. So in this is the top plate and this is the bottom plate. Then the top plate is subjected to some force, tensile force P. Even the bottom force is also subjected to the tensile force P here. But the problem with this lap joint here is, you can see that clearly you can see that from the diagram, the line of action of this force is this, and the line of action of this force that is subjected to the bottom plate is like this. So the line of action of the force is not coinciding here. So there is some eccentricity here between these two line of action of the forces. So that means whenever there is an eccentricity, it will create a moment. So even though you are applying an axial force to the joint here, this will create a bending moment these two forces will create a bending moment in the joint. So that means in addition to this axial force, the joint needs to withstand a bending moment. That means, or else what happens is, even though you prepare a straight plate and you join it, so because of the bending moment, this joint or these plates will be bent something like a curved shape. So that is the disadvantage of this one, lap joint. So whereas if you take the butt joint here, so I kept the two plates side by side and they are subjected to a tensile force something like this. So now the line of action of these two forces are coinciding with each other. So there is no bending moment or no couple. So you don't have any eccentricity. This eccentricity is 0. Then the bending moment is 0. So that means there won't be any bending moment in case of this butt joint. So whereas in case of lap joint, there is, in addition to the tensile load will create a bending moment in the joint because of the eccentricity between the load lines. So this is the load line and this is the load line. So these two are not on the same line. So there is some upside distance between. So this load line passes through the center of this plate and this load line will pass through the center of this plate. Definitely there is a upside distance between these two load lines. Because of that, you have a bending moment. So that is the advantage of this lap joint. So in case of butt joint, you don't have that bending moment. But the disadvantage of this one is, in case of butt joint, you require additional cover plates. In case of lap joint, you don't require any cover plate. In case of butt joint, you require the cover plate. So whether it is single cover plate or some cases you may go for the double cover plate also. But in case of double cover plate or single cover plate, since you are using the additional plates, so the cost of joint is more when compared to the lap joint. So in case of lap joint, you are not using any additional plates here, whereas in case of butt joint, you require the additional plates, which will the joint cost will increase with that additional plates. So that is the disadvantage of this riveted butt joint. So okay, join class. అందరు కొత్త జాయిన్ అవ్వాలి, ఫస్ట్ సెక్షన్ పడేస్తారు, సెకండ్ సెక్షన్ పంపించచ్చు వీళ్ళందరినీ. Okay, right. So if you these are the advantages and disadvantages of this lap and butt joint. Maybe in this picture you have shown it wrongly here. Actually, this arrow should be here. So the force is applied to the only the plate. So this is wrong. He shown it as wrongly. But here he has shown it is properly only. So I have taken this here somewhere from the internet or maybe some other book. That is the error or mistake from that book or maybe whatever maybe the source I have taken. Load is something like this. Always the load line is in the same line in case of butt joint. In case of lap joint only there is a eccentricity. So bending moment is going to be the disadvantage in case of lap joint, and additional cost of the cover plates is going to be the disadvantage in case of butt joint. So that you remember that. So strength wise, then if you want to look at only strength point of view, butt joint is going to have more strength when compared to this, because here only axial load is there. There is no bending load in case of butt joint. Whereas if you look at the cost wise, so then lap joint is going to be the cheaper one when compared to the butt joint. Okay. Anyway, after that we discussed about different types of riveted joints based on the number of rows of rivets. So we discussed all these things. Again, we discussed about the type of riveting, also chain riveting and zigzag riveting, and also we discussed about the diamond riveting also, and we discussed about this caulking and pullering. After these two, so these are the two processes which are using for the tightness, to prepare the tightness of the joint. So only difference between the caulking and this pullering tool is, in case of pullering, the width of the tool is equal to the thickness of the plate. So whatever thickness you have here for the plate, the width of the tool is also like that. Whereas in this case, it is not the so. It is you have a caulking tool as there, some sharp edges there. So generally, people will prefer pullering when compared to the caulking, because of sharp edge of this tool, sometimes it may damage the joint here. Instead of making it as a leak proof, it may damage the joint. So that's why this process is not preferred and compared to this. Then after that, we have seen different definitions for the pitches. That is pitch, back pitch or transverse pitch, diagonal pitch, then marginal pitch. So we discussed these things. Then after that, I have shown some pictures where you can identify the repeating section of a given joint. So based on that, you can design the joint. And this is another type of joint, which is a diamond type of joint. So today what we'll do is, first we'll discuss how to identify the efficiency of the joint. Then we'll take up one problem, how we can design the structural joints. So later we'll go to the boiler joints also. Okay, so I think this is already we discussed. I am skipping all these things because already these things are discussed in the class. Okay, so this is the next topic, that is how I can estimate the efficiency of the joint. So the efficiency of the riveted joint is defined as, it is a ratio of strength of the joint to the strength of the solid plate. So this is the definition only. So but what is the strength of the joint and what is the strength of the solid plate? So now here for you I have shown two pictures here. See, this is a single plate without having joint. So then I'll call it as a solid plate. Solid plate means a plate which is having no joints. So actually in some application I required a plate of this much length, but since this much length of the plate is not available, then what I'll do is I'll take the two pieces of the plates and then I connected these two pieces by riveted joint here. So then I cannot call it as a solid, this one as a solid plate. So because there is a joint here. So since you are making a joint to these two plates to such that the length of the plate will become like this. So then, whatever may be the strength of this plate, it is not equal to strength of this plate. Why? Because here you have a joint. So now, here you have a continuous member, so which is having no irregularity or nothing. So it is a continuous thing here. You don't have any joint kind of thing in this case. So therefore, strength of the solid plate is more than strength of this riveted plate. So that means here this riveted joint, whatever riveting you are doing that here. So we already discussed that riveting process also. We need to drill the holes in the plates, or maybe that it need not be a drilling process. Sometimes you go for punching process also. Either punching or through drilling, you have to create the holes in the plates. So that means whenever hole is there, geometric discontinuity is there. So because of that, there is a stress concentration. Then you are connecting that one through some rivets and cover plates, something like this, whatever maybe, whether it is lap joint or butt joint. So then this process or the joining process will weaken or the strength of this entire plate. Now by joining these two plates through riveted connection, whatever may be the strength of this plate, if I take the strength of the plate is P1, this P1 should be definitely less than this P0, where this is the plate having no joint, so we call it as a solid plate. Then this is the plate which is having a joint, connection is there. So you cannot create a joint which is having 100% same as this one. So that's why the strength of this plate is less than the strength of solid plate. So therefore, always your efficiency then, if it is equal, your P1 is equal to P0. So then what is the efficiency? If P1 and P0 are both are same, you will get efficiency is 1. That means it is 100%. But always your P1 is less than P0. So therefore, you cannot achieve 100% efficiency. 100% efficiency means it is a continuous member. There is no joint. So you have a single solid plate. But because you are joining these two plates by through joint, so it is not a single solid plate. So definitely the load carrying capacity of the joint is less than the load carrying capacity of the solid plate. So therefore, the load carrying capacity of the joint divided by the load carrying capacity of the solid plate is nothing but the efficiency of the joint. So that is what I written here. The efficiency of the joint is nothing but P1 divided by P0. So P1 is the load carrying capacity of the joint to the load carrying capacity of the solid plate. So like I already told, always the efficiency is less than 100%. So now how I can estimate this is straightforward, simple. So when I have a solid plate, so I can easily calculate what is the tensile load carrying capacity of the solid plate. So here that is nothing but, so let us say this is made of some material. This plate is made of some material, let us say steel. So for steel, we know the yield strength. So then straight away you can calculate what is the load carrying capacity of this one. That is the allowable stress in this plate multiplied by the area of the plate. You will get the PO. Straight away you can calculate it. If it is a solid plate, how much load it can carry is calculated based on the allowable stress in this material multiplied by the cross section area. You will get P0. Whereas you cannot use the same formula for this also. Why? Because here you have a riveted connection and the connection is made of some different parts. So you have a connecting plates, these two connecting plates, and you have a cover plates, and you have a rivets are also there. So in the process we are creating some holes in the plate. So therefore simply you cannot use whatever formulas you are using for this solid plate, you cannot use the same thing for this. So now to estimate the strength of this riveted joint, what I need to do is, first I should understand if I apply a tensile force to this joint, in how many ways there is a probability of, or there is a chance of failure of the joint. So the joint may fail because here it is, you have only one plate, single plate. If it is subjected to tension means it is going to fail by tensile load. When the individual stress is more than the yield strength or allowable stress, it is going to fail. Simply I can say that it is going to fail by tension. Whereas here I have rivets are there, covering plates are there, and these two plates which I am joining. So then I can say the joint is going to fail if these plates are failed to carry this load, I can say it is going to fail, or the plates are not failing here, but if the rivets are failed, then also I can say the joint is failed. Or else, if I have a cover plate something like this, I have a cover plate something like this, if this cover plate is failed, then also I can say that joint is failed. So that means here the failure of the solid plate depends upon only the particular plate strength, whereas here you have a combination of elements are there. So therefore that means I need to first identify what are the various ways of the joint may fail. Then based on that I need to take that what is the load carrying capacity of by taking into the all possible types of failures, I need to take the least loading carrying capacity of the joint. So then that is going to be the strength of your joint. Once I know that, then I can calculate the efficiency of the joint. So to do that, first we'll see in what way the joint there may be a probability of failure, or what are the different ways of a riveted joint can be failed. First we'll discuss that. Then we'll calculate, estimate if that is going to be the failure mode, then what is the strength of the joint. So we'll estimate those things. Then based on that we can calculate the efficiency of the joint. So in that, so the first type of failure, maybe like I already said, there may be a different ways of failure. So first we'll consider that if the joint will fail when the rivet is failed like this. So this is what we'll call it as, here the rivet is splitting into two parts. So at the connection, so wherever these two plates, at the junction of these two plates here. So before failure, your plate is somewhere here and it is connected here something like this. So the joint, now if I apply a force here, a tensile force here, I am applying a tensile force only, but this tensile force will act as a shear load on this rivet, because here the rivet is shearing off. It is shearing off into two sections or two portions. So therefore here this is one kind of failure. That means because of if the magnitude of this PS such that there may be a possibility of the joint failure just by shearing of the rivet. So this is one kind of failure. So that means what is happening here is, you can see in the front view also, here you can see that the rivet here the rivet is sheared, or that means it is broken into two pieces. Top one is corresponding to the top plate and bottom portion is corresponding to the bottom plate. So it is cut into two pieces at the interface of these two plates. So then this kind of failure, what we call it as a shear failure of the rivet. So then if this load, so that means if whatever load I am applying here, this PS, if it is less than the shear carrying capacity of this rivet, the joint may not fail in shear, or the rivet may not fail in shear. So that means that you can say that the joint may not fail in shearing of the rivet. So as long as the shear carrying capacity of the rivet is more than the applied load, the joint is not going to fail in shear. That is the condition we need to look at it. Or else, if the shear carrying capacity of this rivet is less than this applied load, so maybe other way, we don't talk about other failure, definitely it is going to fail under shearing of this rivet. So this is the first type of failure that I can say, that is shearing of the rivet at the connector. So here it is connecting here at this location, it is going to be shear off. So now if I want to estimate what is the shearing strength of this rivet, so then what I need to do here is, we know the load is nothing but the shear area multiplied by shearing stress. Suppose if tau is the allowable shear stress in the rivet, then the tau multiplied by the shearing area is going to be the PS. So that's what I showed here. Here what is the shearing area here? The shearing area is nothing but the cross-section area of this rivet. That is, here the rivet is having a circular cross-section, so its area is 5/4 d square. 5/4 d square is the shearing area and tau is the allowable shear stress. Then the shear carrying capacity of this rivet is given by tau into AS. So that is going to be our PS value. So that's what I shown it here. PS is equal to area of shear into tau. Area of shear is nothing but 5/4 d square into tau. See here, sometimes here you can see that in case of lap joint you have only single shear. But if you take a butt joint, in case of butt joint you have a what you can say, double shear also there. So therefore, depending upon whether it is single shear or double shear, you need to include that factor also here. So if it is a single shear, we will take it simply 2 into S into tau. If it is double shear, you need to take it as 2. Maybe actually you have to take it as 2. In most of the riveted joints, instead of 2, they will take it as 1.85 as the factor for the double shear. Anyway, we will discuss that later. So this is one kind of failure the joint may fail. That is, by shearing of the rivet, the joint may fail. This is one kind of failure. So if that is the case, you can estimate what is the shearing strength, or you can estimate the joint strength. The joint strength is nothing but only here it is PS. This PS is area of the shear multiplied by the shear stress. So this is the formula to calculate that. So once I know the material of this rivet, I can easily find out what is the allowable shear stress. You have a static failure theories. So since it is a shear, you need to take here the allowable shear stress is nothing but SYS, that is allowable yield strength of the material divided by the factor of safety. That is the case. Or sometimes in the problem directly they will give you. So let us say some 40 mega MPa is going to be the allowable shear stress. Like that also they will give. So based on the given data, you can easily estimate what is this PS. Then coming to the next type of failure. So this is the first one is first type of failure is the rivet is shearing off at the connection. That is the first type of failure. Then the second type of failure is tearing of the plate. So here the rivet is not failing. The rivet is stronger only here, but so the plate is weaker here. So wherever it connected here, the plate is tearing off into two portions here. So this is one portion and this portion. So the joint may fail like this also, provided your plate is weaker than your rivet. So this type of failure will happen when the rivet is weaker one. So now if the rivet is stronger than the plate, then this type of failure may occur. So that is, the plate is tearing off into two portions here. So here you clearly see that the plate is subjected to a tensile load now here. So we'll take it as tearing load as a PT. Here the rivet is subjected to shear load here. Shear, we are taking that one as a PS. So here, since the plate is failed by tensile load here, we'll take it as PT. And if I take the allowable tensile stress in the plate is some sigma T, then I can calculate the tearing strength of this plate also. That is nothing but sigma T into the area resisting this tearing failure. See, whatever I highlighted here in the green, so this is going to be the area which is resisting this tearing failure. So then you will get your PT, that is nothing but we'll call it as PS, we'll call it as a shearing strength of the joint, and PT we'll call it as the tearing strength of the joint. So it is sigma T into the resisting area. Here also we do the same thing. Shear stress into the resisting area. Here also you need to take the allowable stress into the resisting area, but only thing is the resisting area is you have to take the tearing portion of the plate. So this is the tearing portion of the plate. So now if I take T is the thickness of the plate and P is the width of the plate. P is the width of the plate and the diameter of the rivet hole is D. Diameter of the rivet hole is D. Then I can calculate the area which is resisting the tearing of the plate. So that means whatever I highlighted here in the green, so this is the area you need to calculate. Suppose if this hole is not there, this total area is, it is a rectangle, whose the dimension is, width is P and depth or thickness is T, area is going to be P into T only. But here, instead of continuous plate, since I have drilled a hole in the plate to insert this rivet, so this much amount of material I removed from the plate. So therefore the resisting area is decreased here. So this distance, only this much area plus this much area. So that means in the total width of plate P, I subtracted D here. So this D into T is not there. So therefore the area is going to be P minus D into T. So if you compute this area, it is going to be P minus D into T. So or else if it is a continuous line, you can take something like this. If you assume the hole is not there, so then what is the area? This is the total rectangle you are going to get. The area of that rectangle is, so with this total distance we are taking it as P. This is P and this is T. So the total area is P into T. But since because of hole is there, I need to subtract this much area here. So how much area I need to subtract now? This much area. So this area I need to subtract. So what is this area? This is D and this thickness again T. So I need to subtract from that area D into T. I need to subtract. So now if I simplify this, what I'll get? I can take T common in both the cases. I can write this one as the resisting area as P minus D into T multiplied by your sigma T, that is allowable tensile stress in this plate, will give you the value of PT. So this is the top view. You can see the failure is going to happen like this, and this is the front view. So here this portion of the plate is tearing off from the joint. So that means it is get separated here. So only in the joint you have only this one. This is get separated here. Whereas here the two plates are separated, but there is no failure in the plate. Only the failure is in the rivet here. Okay. So this is one kind of failure and this is the other kind of failure. That is, first one we'll call it as shearing of the rivet or shearing strength of the rivet. From that we'll calculate the shearing strength of the rivet. Second one we'll call it as a tearing of the plate. So from that we'll calculate the tearing strength of the plate. So okay, that's what I shown it here also. PT is nothing but AT into sigma T, or AT is nothing but the tearing area. Tearing area is nothing but P minus D into T, multiplied by the allowable tensile stress sigma T will give you the tearing strength of this joint. So this is the second kind of failure. So then you have one more kind of failure, that is a bearing failure of the plate. See, this is, there may be a possibility of something like this also. Here you have a joint, is the riveted joint is made here. When you apply a tensile load to this plate and this plate here, if the plate is having a less compressive strength here, so then if you apply a tensile load, what happens is the plate will move like this and this plate will move like this within the circumference of the rivet. If the plate is not having sufficient compressive strength, what happens is this plate will be crushed out here and are bearing. Because of this bearing stress, the hole at the joint is going to be enlarged something like this. The hole is going to be enlarged by something like this. So then this type of failure, even if you have this is happened, your joint is not going to withstand any load here. It is, we can say that it is going to be failed only. So the joint is going to fail because it won't carry your purpose of the joint. So that means we are creating it for the strength and as well as tightness. If this kind of hole is created here, so leakage can happen through the joint also. So that means we can say that joint is failed. So then to identify that what is that crushing strength or bearing strength of the joint, both are same. Crushing and bearing, we'll call, sometimes we'll call it as bearing stress and sometimes we'll call it as a crushing stress. Both are same only. So if you want to estimate that, then again, if you know allowable crushing stress, then multiplied by the crushing area, you will get the crushing strength. So like what we discussed in the previous classes also, whenever there is a bearing stress, you need to make use of the concept of the projected area. So here the projected area of the connector hole, if I take that, so if I take this hole, if I projected that one to the plate here, this is going to be the area what you are going to get here. So then in that case, so the area of this projected area is nothing but this dimension is D, that is nothing but the diameter of the hole, and this height is going to be the thickness of the plate. So therefore your projected area is going to be D into T only. So therefore the bearing strength of the joint is going to be sigma B, that is the allowable bearing stress or crushing stress, multiplied by the bearing area, which is nothing but D into T. So you'll get the bearing strength of the joint. So PB, which is nothing but AB into sigma B. Your AB is nothing but the bearing area or projected area, so which is D into T multiplied by sigma B. So like that I can calculate PB. But so far I have shown three kinds of failures. In all the three kinds of failure, I consider only one rivet. If you take this, or if you take this, or even in this case also I taken only one rivet. Suppose if I have more than one rivet, so that means if it is a lap joint having only one row here, so if I go for another row, that means I have one more rivet is here. In that case, what I need to do is, if I want to calculate the shearing strength of the rivets, so if I have two rivets, then I need to multiply this one by 2 here. Here also, and either side I need to multiply by 2. If I have, so that means I can include, I want to here this PS, if I want to write an expression for PS, then what I can modify this one is N into AS into tau. I have to take something like this, where N is the number of rivets. So in this case, I have only one rivet, so I'll take N is equal to 1. If I have two rivets here in the same line, I have two rivets, then I'll go for N is equal to 2. So that means the two rivets are carrying this total load now. When you have only single rivet, the single rivet is carrying the shear load. If you have two rivets, the two rivets will carry the shear load. In that case, I have to use N is equal to 2. Similarly, three rivets are there, 3 like that I need to use. Similarly, case here, suppose for the same plate, if I use two rivets here, then that means there are two holes in the plate. There are two holes in the plate. If P is the total width of the plate, then the tearing area is going to be P minus 2D you need to consider here, or ND. If I take N is number of rivets, you need to consider N into D is going to, P minus N into D is going to be your tearing area. If there is only one hole, I will take N is equal to 1, so it will become P minus D. If I have more than one hole, so therefore there is a material removal in more than one location, I have to use those many number of equations. So if two holes are there, I have to take P minus 2D. If 3 holes are there, I have to take P minus 3D, something like that. Similarly, here in case of this bearing failure also, if I have more than one rivet, so then I need to take this formula here, I need to multiply this one by N, where N is the number of rivets. If you do it for the single rivet, these are the equations. If you have a multiple number of rivets, you need to multiply all these strengths by number of rivets also. In case of first one and last one, so tearing is corresponding to the tensile strength of the plate, shearing is corresponding to the rivet, even this tearing is also, bearing is also corresponding to the plate, but it depends upon the number of rivets also. Okay, so now I'll estimate, generally these are the three kinds of failures which is the joint is going to happen. Joint is going to fail, either the plate may tearing off, or the rivet may shear off, or the plate may fail by bearing crushing stress at the location of the rivet. So these are the three most general failure ways. Apart from these three, you have two more failures, that is tearing of the plate at the margin and also shearing of the plate at the margin. So these two things are most unlikely to occur. Why I put it as most unlikely to occur here? Because if we provide proper margin M, so we discussed what is a marginal pitch. If we provide a proper marginal pitch, so these two kinds of failures are not going to happen. So that's why it is unlikely to occur in all the joints. So there are standards. There are standards for how much margin you need to provide. Generally, in case of all the joints, the margin should be 1.5 times D, where D is the diameter of the hole. So if you provide this, either this shearing of the connector, shearing of the plate behind the connector, you can avoid this type of failure. And again, the tearing out of the plate at the edge here. Here the plate is tearing off into the two pieces at the edge. So this kind of failure also you can avoid just by providing proper margin to the joint. So margin is nothing but the distance between the center of this hole to the edge of the plate. This is the margin. If I am able to provide the sufficient margin, then these two kinds of failures can be avoided in the joint. So that's why while designing the joint, the first three only we consider as a failures. So these things, these two types of failures can be avoided just by considering the proper margin. So that's why we are not going to consider these things as a failures for the joints. So that means we won't consider these things while designing the joints. These two failures we won't consider while designing the joint. So that's what is written. If the distance from the edge of the plate to the connector is large enough, so 1.75 to 2 times the diameter of the rivet connector. So average is 1.5 here, but he has given it as 1.75 to 2 times the diameter of the rivet. rivet of the diameter of the connector. So then you can avoid these two kinds of failures. So basically, while calculating the strength of the joint, we need to look at into only those three. So this one will ignore it. Only will calculate what is PS, that is the shearing strength of the joint. We'll calculate what is the tearing strength of the joint, and we'll calculate what is the bearing strength of the joint. See, I'll say strength of the joint. Joint means even though it is a shearing strength of the rivet, your rivet is part of the joint. So therefore, whatever may be the shearing strength the rivet is having, that is going to be the shearing strength of your joint. So simply I'll say shearing strength of the rivet is same as shearing strength of the joint. Similarly, tearing strength of the plate is same as tearing strength of the joint. And also bearing strength of the joint itself is nothing but the bearing strength of the plate. So like that, we'll use these terms interchangeably. Sometimes I'll say shearing strength of the rivet. That is also same as the shearing strength of the joint also. Similarly, tearing strength of the plate is same as the tearing strength of the joint, because plate and rivets are part of our joint. So therefore, so we'll identify those three strengths, that is the shearing strength of the rivet and tearing strength of the plate and bearing strength of the plate. So again, so I said that these are the three possible ways of failure. So that means if the rivet is failure, rivet is failed, we can say the joint is failed. If the plate is teared off, we can say that is going to be failure. Even if the plate is failed by bearing stress, then also you can say the joint is failed. So then to identify that strength of the joint, so what we need to do is, like in the beginning, at the beginning we discussed that the efficiency of the joint is nothing but the strength of the joint divided by the strength of the solid plate. So now we need to identify, here you have three strengths, that is shearing strength, tearing strength and bearing strength. So now out of all these three also, what is going to be the strength of the joint? If you want to identify out of all the three, which one is going to be the least? Either tearing strength or bearing strength or shearing strength. Out of these three, you need to take the least value. So from that least value, whatever may be the least value is there, that is going to be the strength of the joint. You cannot take the highest value as the strength of joint, because let us say if you take the highest value and you can say the joint is going to capable of carrying this much load. If I apply the highest strength, load for the highest strength, then it may fail in the other mode where it is having a lowest strength. So that means, let us say the tearing strength is 50 MPa, bearing strength is 20 MPa, and then shearing strength is some 40 MPa. So now, if I apply 50 MPa load to the joint, so it is going to fail by shear as well as bearing. So you cannot take like that. Highest value you cannot take that. So if the load is less than 20 MPa, then only the joint is not going to fail. So that means the 20 MPa, less than 20 MPa is always more than your bearing strength as well as tearing strength as well as shearing strength. So therefore you can say the joint is safe. So therefore the least of these three values we will take it as a strength of the joint. Then if you know the strength of the joint, then you use that formula to compute the efficiency of the joint. By comparing it, the strength of this joint to the strength of the solid plate, we will get the efficiency of the joint. So this is how we can identify the efficiency of the joint. So then what we'll do is, we'll take up some problems on this. So first what we'll do is, I'll take a structural joint, how I can go into design the structural joint. Then we'll go for boiler joints also. So okay, I'll skip these things. We'll come to this later. I'll go through the problems right away on structural joints. I'll skip. Anyway, we'll come back and we'll discuss these things. Yes. So this is the problem first what we are going to discuss. I want to discuss. See here, find the safe load. It is a lap joint only. So generally I already told, in case of structures, we'll use only lap joints, like a trusses or bridge structures, whatever, wherever it is there, railway bridges, we'll use this kind of diamond joint, and the joint is also going to be used. What is the reason they are going for the diamond joint here? If you go for this kind of joint, the material required for the plate is less. If you go for this diamond kind of joint, So if you go for the solid plate, that means I require this much plate. So therefore, here this is the here you are having a less area for the plate and compared to this. So that is the advantage of this diamond joint. Okay. So now we'll see how we can design this joint. So but it is not a design. What he asked us, find the safe load, the lap connection. Connection is nothing but joint only. Shown in the figure. If the rivets are of 19 mm diameter and the plates are 8 mm thick. Use allowable stress for tau. Tau means shear stress 95 MPa, sigma T 140 MPa, sigma B 220 MPa. So that means he has given all the allowable stresses. That is allowable stress in tension. That is nothing but tearing strength. So which is 140 MPa, bearing stress is 220 MPa, and allowable shear stress is 95 MPa. He has given. And he has given the joint also, and he has given how many number of rows are in the joint also. 1, 2, 3, 4, 5 rows are there. So here we need to identify what is the load this joint can carry. That is the safe load. So that means the maximum load it can carry. We want to compute that. So for that, like I already told, we need to estimate all the three load carrying capacities. That is shearing strength, bearing strength, and then tearing strength. So out of all the three, we need to take the least one, and from the least value, you can take that one as the load the giant can carry. You can take that one as the load the giant can carry. So that is the answer for that. So for that, first what we'll do is we'll consider the shearing strength. So now we already seen the formula for the shearing strength. So shearing capacity of, suppose here, like I already said, if there are number of rivets are there, you need to multiply that by the number of rivets also. But first we'll compute for one rivet. So for one rivet, what is the shearing strength or shearing capacity? PS is nothing but tau into 5/4 d square. So here he has given the diameter, all these things. So now I can compute that is tau allowable. Tau is nothing but the allowable shear stress, which he has given it as 95 MPa. 1 MPa is 1 Newton per mm square only. No need to convert here this anything here. So 1 MPa is 1 Newton per mm square only. So diameter I am taking in mm. So I'll get PS as tau is 95, 5/4 d square is nothing but I'll get in newtons. So if I compute this value, I got this one as 26.935 kilonewtons. Okay, so this is the shearing capacity or shearing strength of one rivet. And then later I'll multiply to compute the total shearing strength. I'll multiply later by number of rivets so that I'll get total shearing strength. Then I'll compute the bearing capacity of the rivet. So in case of the bearing capacity of one rivet, so our formula is PV is nothing but sigma B into AB. So that is nothing but your area, bearing area. Bearing area is nothing but D into T only. So in that case, sigma B is equal to T into BB, T into D. So he has given the thickness of the plate for you, which is 8 mm, and diameter is 90 mm. And this bearing stress also has given you allowable bearing stress 220 MPa. So if I substitute that into this formula, I get this is going to be the bearing capacity of one single rivet, or one rivet. So which comes out as 33.44 kilonewtons. Of course here, if you substitute it here, this is we got in newtons. I'll divide this one by 10 cube, then I'll get in kilonewtons. Okay. So then, if I want to calculate the total for all the rivets, what is the capacity? So then what you have to do? You have to multiply this one by number of rivets. How many number of rivets are there in this? 1, 2, 3, 4, 5, 6, 7, 8, 9 rivets are there. So therefore, I need to calculate what is the total load carrying capacity of these rivets. That is 9 into. Why I have taken the total rivets carrying capacity? See again, like we already mentioned, we need to take always you need to take the lowest one. So out of this bearing capacity and shearing capacity, which one is the least one? Here, this shearing capacity is the least one. So therefore, the joint, I am not going to design the joint, or I am not going to take the load based on the bearing capacity. Only first, if I compare these two, this is the weaker one. The rivet is the weaker one when compared to the bearing capacity. So I will estimate the load carrying capacity based on the rivet's shear. So therefore, it is going to be 9 into. For each rivet, it is a 26.935. If I compute that, I'll get that one as 242.42 kilonewtons. Or similarly, you can take the bearing capacity also. What you need to do is, you need to multiply this one also by 9. Then if I compare these two, out of these two, this is going to be the least one. So that I will take it as the load carrying capacity of rivets. Then we need to, we checked only two things. So then we have another thing, that is the tearing capacity of the plate also we need to take. So that also we need to consider. So to find that, first we need to identify what is the diameter of the hole. So here he has given the diameter of the rivet is given, but we'll use, this is the empirical relation for diameter of the hole. I already mentioned in the previous class also, diameter of the rivet hole is nothing but diameter of the rivet plus 1.5 mm. Or if you don't know this, so if you use your data book, in the data book, corresponding to the diameter, rivet diameter 19 mm, what is the diameter of the hole? You can take that from the data book also. If you take that from data book, use that value, or else you can use this empirical relation. So diameter of the hole is nothing but diameter of the rivet plus 1.5 mm. So then I'll get the diameter of the rivet hole, which is 20.5 mm. Now I'll calculate the tearing strength of the plates also. Here, first if I consider this row, so if the plate is tearing off at this location, there may be a chance of the plate may be tearing off here, or it may tear off here, or it may tear off here. So this side also is same, at this location, at this location, both are same. This is similar to this. So if I consider up to these three sections, that is sufficient. So now I will explore all the three possible values. The plate may be tear off here, or it may be tear off here, or it may be tear off here. So first if I take this option, then what is the tearing strength of the plate? So in that case, see here, this is the section view. If the plate is tearing off at this location, so then this is the allowable tensile stress or tearing stress in the component. Then I am applying a load, something like, let's say PT, I can take it as PT. So why I am not taking directly this one as PT? Because we have different possibilities of failure by tearing. So that's why I'm taking P1, P2, P3, something like that I'll take. So now this is, if I take a section here, this is a failure. So then what is the allowable load here? You can take, so this P or this length, whatever maybe the length is there, this length is, he has given it as 250 mm, 250 mm minus this diameter of the rivet hole, which is 20.5, multiplied by the thickness of the plate. You need to take thickness of the plate, he has given it as 8 mm. So multiplied by this allowable sigma t, you are going to get your P1. P1 is nothing but sigma 1 into L minus diameter of the hole into T. So if I substitute whatever the numericals he has given in the problem, we get it as 257 kilonewtons. But still, simply I cannot take this one as the tearing strength of the plate, because you have two more ways of failure by the plate failure by tearing. It may tear off here, or it may tear off here, or it may tear off here also. So therefore, I need to estimate what is the tearing strength when the plate is tearing off here or here. So for that, that's why I am not taking this one as the final tearing strength of the plate. So this is only one instant. Then next I will take, if the plate is tearing off here, what is its strength then? So for that, if it is something like this, so this is the section of that plate when it is tearing off at this location. But before going to the tearing off, here we need to understand one important point. So here, this plate, whatever maybe the plate is there, if it is broken into two pieces means like this. So at this location, this side will come out of like this, and this side will come out of like this. So when it is going to happen, if this side is coming this side like this, so then here before this is happening, so here you have a rivet here. So if this rivet is failed, then only the plate can move like this. If the rivet is failed, then only the plate can tear off like something like this. That means as long as if this joint is not failed, so this plate, whatever plate you have here, this plate cannot move like this. So that means in order to take tearing takes place at this section, first this rivet should fail. So that means the rivet should fail in shear here. So always the rivets will fail in shear. So that means, so the tearing capacity, if you want to estimate the tearing capacity of the plate at this location, what you need to do is, you need to consider what is the shearing strength of this rivet. Then at this location, you need to consider what is the tearing strength. So that I taken that one as a P2. So we already estimated this one, that 26.94. How I got this one? We already estimated the shearing capacity of one rivet, 26.935. maybe I rounded off this to 26.94. That's what I shown it here. 26.94 is there. Then here you are getting the tearing here, so you need to compute the tearing strength of the plate. So therefore your P2 is nothing but here. So this is the P2 diagram. Or else you can take this one plus this. You can take like that also. So P2 minus 26.92 is equal to your sigma T into area here. So like I already mentioned earlier, here you have a two holes are there, not a single hole. If single hole is there, in the previous case you have a single hole. So I taken L minus D, L or P, or sometimes we take it as pitch itself. L minus D here I have taken. Since at this location here you have two holes are there, you have to take L minus 2D you need to take. That's what I have taken here. So then if I compute this or if I simplify this, I'll get P2 as 261 kilonewtons. Similarly, I'll consider if the tearing is takes place across these three rivets, then what is the tearing strength? So then this is going to be the three body diagram now. So the tearing is going to happen at this location only when these three rivets are failed. First, if these three rivets are failed, then only the plate is going to tear off here. So therefore, I need to consider the tearing strength of these rivets also, shearing strength of these three rivets. So here I have three rivets. I need to consider the shearing strength of the three rivets plus the tearing strength of the plate. I need to consider. So if I do that, that is equal to your P3. Your P3 is equal to, so this is the shearing capacity of the three rivets. Then your tearing capacity of the plate at this location, it is nothing but sigma T into, since you have a three holes here, you have to take L minus 3D. So if I substitute the numericals for this, then if I simplify this, I'll get P3 as 291.9 kilonewtons. Now you have P1, P2, P3. So out of these three, you have to take the least one as the tearing strength of the plate. So P1 you got it as here 257. Then you got 261. Then you got it as 291. So now out of all these three, so least one is going to be only this one. 257 kilonewtons is going to be the least value. So now for the joint, now I know the tearing strength. The tearing strength is 250 kilonewtons, 257 kilonewtons, and shearing strength is 240 kilonewtons, and bearing strength is this 33.44 into 9, which is more than this. We may get around 280 or 290. So out of all these three, again, what I need to do is I need to take the least value. So therefore, this is the highest value. I am not considering this. Then if I compare these two also, in these two also, this is going to be the least one. So therefore, the load carrying capacity of this joint, I can take it as only 242.42 kilonewtons only. 242.42 kilonewtons. So this is going to be the maximum load the joint can carry without failure. Suppose if I increase the load, if I take 250 kilonewtons is the load the joint can carry. If I take like that, since your shearing capacity is less than, that is which is 242 only, if you apply 257 newtons, so the rivets will fail by shear. So that means the joint will fail. Similarly, if I take, this is the criteria, if I take PB as my load carrying capacity of joint, so let us say it is 300. So if I apply 300 kilonewtons, both your rivets will fail as well as the plate will also going to tear off. So therefore, always you need to look at into the least value and you need to take that one as the strength of the joint, right? So this is how you can design the joint, or you can, here it's not a design actually, it is how you can calculate the safest load the joint can carry. So this is how you can do that. So maybe in the last thing, okay. So I estimated the efficiency also. Efficiency is nothing but simply the least of those three. So I have taken that one is 242.42 is the least load carrying capacity. Then efficiency of joint is nothing but if you take the entire plate it's a single one. So the here the width of the plate is 140 and thickness is 8. This is the allowable tensile stress, and width here taken it as 250 mm and thickness is 8 mm. So this is the strength of our solid plate. So 140 is the allowable tensile stress. That's what he has given in the problem itself. So here 140 is the allowable tensile stress. So from that you can calculate the efficiency of the joint also. See, you can see that the efficiency is definitely less than 100%. Here we got only 86.6% is the efficiency for the joint. So like this you can find the efficiency of joint in case of structural joints. So similarly, we can consider the boiler joints also. Maybe we'll see those things in the coming classes. So today I'll stop at this point. So we'll continue in the next class. Only important point here in into while designing this one is, so steering and bearing capacity calculation is straightforward. Only while calculating the steering strength, you need to consider here if the plate is tearing off here, you have to consider only tearing strength. If it is tearing off here, you need to consider steering strength of this rivet plus steering strength of the plate at this location. You need to consider. Similarly, in this location also. Out of all those three, then again you need to choose the least value. So from that least value, again you need to compare PD, PS, PB. Out of all the three, you have to take again the least value, least of PS, PB and PT. Then that will take as the strength of the joint. So from that you can calculate or you can estimate the efficiency of the joint. Right? I think it is clear. I hope it is clear. If any doubt, you can ask, or else we'll discuss in the next class also. Any doubt are there? If nothing is there, then you can close. You can close. You have, okay, maybe any next one is lunch break only. Okay, I need also going to go to the lunch. If you have any doubt, you can ask. Otherwise, I'll close the class. That's it. First, I'll stop the recording.